Okay, so here is question number 11 to 16. In the 5 by 5 grid given below, 25 consecutive positive integers starting from x are to be arranged such that each integer except x and x plus 1. So except x and x plus 1, each integer can be written as the sum of two numbers present in its neighboring cells. Now, what are neighboring cells? Generally, they would tell you about it. So, some integers are already filled in disguise. Integers in the grid are neighboring cells if their cells touch along a side or at a vertex. So, even if the vertex touches, that's called a neighboring cell. If the side touches, that's a neighboring cell. Each integer is used exactly once. For example, x plus 1, x plus 2, x plus 3, etc. They are neighbors of x. So, when I talk about this particular cell, so this particular cell has got these four sides. So anyone who is touching these sides, so this, and this, they all would be neighbors, or anyone touching their vertex. So these are the four vertices as well. So anyone touching the vertex are these four. So they all are the neighbors of cell X. And he says all the numbers are different as well. Now we just have to fill up the table. That's what we have to do. And these are the questions that we have to answer on this. Of course, once the table is complete, after that we can easily answer all those questions. Now I made an empty table and another table over here. He has already told us these are 25 consecutive positive integers. Consecutive positive integers. I see a value as x. I see x plus 1, x plus 2, x plus 3 up to x plus 8. I also see x plus 4 square minus 2, x plus 4 square, and x plus 4 square minus 1, x plus 4 square minus 3, minus 4, minus 5. The smallest among them is x definitely, and the largest among them is x plus 4 square. If I look at the smallest positive integer, which is 1, if I take x as 1, x plus 4 square comes out to be 25. I can have 25 consecutive integers from 1 to 25. But even if I take x as 2, x plus 4 square will be 36. And from 2 to 36, I cannot have 25 consecutive integers. Of course, if for the larger values of x, this gap would keep on increasing now. Even 2 and 36 has a higher gap. So therefore, the only possibility for x is 1. I will have to write x as 1 because no other case will give me 25 consecutive numbers. Rather, they'll give me more numbers than that. I needed consecutive 25 only. Okay. Now 1 is here, 1 plus 2, sorry, 1 plus 1, 2 would be written over here, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and then 6, then I have 7, then I have 8, sorry, 8, and I have 9 over here. So these are all the values that I have already written. Of course, all of them would be the sum of their two neighboring cells, and he had clearly written it is except x and x plus 1, except x and x plus 1, because 1 cannot be written as sum of two numbers, 2 cannot be written, 3 can be written as 1 plus 2, 4 can be written as 3 plus 1, and that ways for everyone you can make so. If I put x as 1 over here, it is 1 plus 4, 5 square, 25 minus 2, that is equal to 23. 1 plus 4 square is 25. 1 plus 4 square minus 1 is 24. 1 plus 4 square minus 3 is 22. 1 plus 4 square minus 4 is 21. And 1 plus 4 square minus 5 is 20. So the bottom 9 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, they all are gone. The top numbers 21, 20, sorry, 20, 21, 22, 23, 24, 25, they are already written. So I just need to fill up 10 to 19 more. I have to fill up 10 to 19 as well. This is all that is needed. Now look at this 25 over here. This 25 should also be sum of two neighboring cells. Two of the neighboring cells are already there as 9 and 24. 9 and 24 cannot add up to 25. And 24 can add up as 25 with 1, but 1 cannot be written over here. So the only possibility is that 9 plus 16 can give you 25. I will have to write 16 over here. Otherwise, no two numbers can add up to 25. So 16 plus 9 is the only possible option through which I could make 25. Similarly, let's talk about this 21. How can I make 21? 20 plus 4 is 24. That does not make 21. And with 20, I have to write 1 to make 21. 1 I cannot write again. So the only possibility is that 4 and 17 can make it 21. So 17 plus 4 makes it 21. That's the only possibility. So now the leftover numbers are 10, 11, 12, 13, 14, 15, 16 and 17 are gone, and I'm left with 18 and 19 as well. So 10, 11, 12, 13, 14, 15, 18 and 19, these are all the numbers which are possible over here. So now I have to fill up these remaining numbers as well at all these places which are left with us. What next? If I talk about this 16, that of course it is made by 7 and 9. How is this 23 made? It is made by 16 and 7. What can I write over here? Of course, there are many possibilities for this number currently because it has got 5 neighboring cells. 2 of them are still to be written. So there would be many possibilities for that. Rather, I would come to this point. I mean, corners are always better to go ahead with. The simple reason is that when you talk about the corners, what is the best part of the corners in such cases? In case of corners, we just have 3 neighboring cells. So for 22, I have one of the neighboring cells as 2. Now 2 can make 22 with 20 only, right? With 2, you can write 20 to make 22. But I cannot write 20 over here. 20 is already there. So that means these two numbers, they should add up to 22. And both of these numbers are taken from them. If from all of these numbers you see, what two numbers can make 22? They are only 10 and 12. So one of 10 and 12 would be here, and the other one of 10 and 12 would be here. One of 10 and 12 would be here, and the other of 10 and 12 would be here. So 10 is also gone, 12 is also gone. I'm left with 11, 13, 14, 15, 18, and 19. What next? Now let's talk about this 20. This 20 should be sum of two numbers, two neighboring cells. 17 cannot add up to make 20 because 13 is already here. 21 cannot make 20. With 4 I can make 20 if I have 16 with it. But I cannot write 16 as well. 16 is already here. The only possibility to make 20, can I say, can be made with 5 only, right guys? 20 has got 5 neighboring cells. 21 cannot add up with anything to make 20. 17 can only add up with 3. 3 is already used. 4 can only add up with 16. 16 is already used. So with 5 only you can make 20, and that can again be made just by using 15. So 15 is also gone. I have all these numbers till now at all of these places, right? Now, 3 of all these numbers would be written at these 3 places. One of these numbers would be written over here, and one of these numbers would be written over here. Okay, let's talk about all other cases now. What all possibilities can be made according to all of them. Now let's find about this number. What can this be? What all can I write over here at this place? If I look at here, can 17 add up to something of these to make any one of these numbers? Yes, probably 17 and 2 can make 19. So there is a possibility of 19 over here, right? Otherwise, 17 cannot add up to any of them. Can 4 add up with any of these numbers to make something over here? So 4 can add up with 11? No. 4 can add up with 13? No. 4 can add up with 14? Yes, 4 and 14, but I don't have 14 as well. So 17 plus 2 can make 19, but 4 cannot add up to any one of them to make any of these numbers over here, right? But I can have 4 plus 10 as 14. 4 plus 10 is a possibility as 14. So I am getting various possibilities for this at this stage. So better is, I'll do one thing. 10 and 12 are to be fixed. Let's take a possibility now that let's say 10 is here and let us say 12 is here. I'm just taking one possibility that 10 is here and 12 is here. If I write 10 here, what can come over here among all these numbers? Can 11 be there? Yes, 9 and 2 can make 11 over here. Can 13 be here? No. Can 14 be here? No. Can 18 be here? Yes, 10 and 8 can make 18. Can 19 be here? Yes, 10 and 9 can make it 19. Oh, there are various possibilities for it. Let's come to this part. What all can come over here? 17 plus 2, 19 can be there. What else can be here? I can have 12 plus 2, 14 as well. I can have nothing else. So I have only two possibilities once again, which is 19 and 16 over here, right? I have just two possibilities, 19 and 16. 12 plus 4 can make it 16 and 17 plus 2 is 19. Oh, but 12 plus 2, 14 is also possible. So once again, I'm looking, there are various possibilities for this number 2. I'm going back to this case now, as I discussed before, that this is one that case which has got limited number of possibilities with it. So it is better to use that number. It has got only 3 neighbors, right? It has got only 3 neighbors. One of those neighbors is 6, and the other one is among these two only. Now, these two numbers are from them. They cannot add up to a number from them in themselves. I mean, 11 plus 13 cannot make a number from them only. 11 plus 14 cannot make a number from them only. They always need a 6 to make a number among them. And that 6 can only give you 19 when you add that 6 with 13. Are you getting it? 6 and 13 only can give you 19 over here. Now, where should I write 13? If I write 13 over here, let's say I write 13. Any two neighboring cells, can they make 13? Of course, they cannot. So, therefore, I cannot write 13 over here in such cases. So, I will have to write 13 here. So, that 13 plus 6 gives me 19. And what can I write here? 13 is gone, 19 is gone. I'm left with 11, 14 and 18. If I'm left with 11, 14 and 18, only 6 plus 5, 11 can come here, or 13 plus 5, 18 can come over here. This number can be 11 or 18. But I also have to make 15 here, and 15 cannot be made by having an 18 over here. How would you be able to make 15? 15 is only made by 11 plus 4. So if I write 11 here, 11 plus 4 only can make it 50, right? So 11 is also gone. And after that, what are we left with? The last two values which are left with are 14 and 18. Of course, one of them come over here. 14 cannot be made by any one of them. So I have to write 18 here. 14 would automatically come here. And that ways we have the complete set now. Now, here you might say that I've just taken a possibility of 10 and 12. What if I take 12 over here and 10 over there? Of course, there would be a contradiction when you start making all those cases. You would not be able to make all possible cases over here. So, once that is not possible, of course, you don't have any other option than to choose them. Okay. So that's all the cases that we are able to form here. What I'm talking about, let's say you take 10 over here and you take 12 over here. So now again, once I take 12 over here, I will have to write 14 only. There is no other possibility. 11, 13 or 19 are used over there. Then here I would not be able to write anything because 18 cannot be made by any of the two neighboring cells. So that will be immediately ruled out, and that gives us the wrong case. So now we just have to look at the table and answer the question. So what is the average of all the integers in the cells of the first column from the left? First column from the left is this: 19 plus 13, 32, 32 plus 23, 55 plus 16, 71 plus 25, 71 plus 25 is 96. So what is the average? 96 divided by 5 values are there. My answer is 19.2. So option C is the correct answer for question number 11. Question number 12 says, what is the sum of all the integers in the primary diagonal cells? That is cells from top left to the bottom right. So top left to bottom right, what is their sum? 19 plus 625 plus 126 plus 228 plus 222, that is equal to 50. So 50 is the right answer for question number 12. Here is 13th. How many different values of x is or are possible? So as we saw initially that x can be only one. So there is only one possible value of x. The answer is 1. That is option A. Which number is j in the grid? If you guys remember, in the original data it was given that this number is j. So therefore j is equal to 14. How many of the given values in any of the 25 cells can be written as sum of the two numbers from its neighboring cells in more than one way? Actually, while doing this set, I would see that I should be leaving this question even at this stage because it is a lot. I will have to check each and every number whether it can be written as a sum of two neighboring cells in two ways, right? More than one way. So checking each number will be very difficult. So you should not be doing this question during the exam time, though I will be discussing it here. Now 19 can only be written by 13 plus 6. No two else can make 19. 11 can only be written by 6 and 5. Others cannot make 11. 15 can only be made by 11 and 4. No two others can make 15. 20 can be made by 15 and 5 only. 21 can be made by 17 and 4 only. 17 is made by 14 and 3 only. 4 is made by 3 plus 1 only. 5 is made by 4 plus 1. 6 is made by 5 plus 1. 7 is made by 6 plus 1. 9 is made by 8 plus 1. 8 is made by 2 plus 1. 2 and 1 are anyways exempted. 3 is made by 2 plus 1. So till now we have not got any number. 13 is made by only 7 and 6. 23 is made by only 16 and 7. 16 is made by 7 and 9 only. 25 is made by 16 and 9 only. 24 is made by 16 and 8 only. 18 is made by 10 and 8 only. And then 10 is made by 8 and 2 only. 22 is 10 and 12 only. 12 is made by 10 plus 2 only. So every number is written only in one way. So my answer is there is no number which can be written as a sum of two neighboring cells in more than one way. The answer is 0. And lastly, what is the sum of all the integers in the last row cells? So these are the last row cells. 25 plus 24, 49 plus 18, 67 plus 10, 77 plus 22. That is equal to 99. So once the table is formed, the questions can be answered pretty easily.